Hello all. In this lecture we'll see about functions in C. So functions are used for this structured programming. So if we want to have solve large problems, it will be better if we break the problem into several pieces so that each piece can work separately. So each piece itself will be a separate problem. So it will be easier to code when we write, or when you write a software, it will be better if you write separate functions. So for example, if you want to write a program to find the sum of two matrices, product of two matrices, then a difference of two matrices, transpose of a matrix in a single program, if you write the whole code in the main program itself, it will be very difficult to understand for the user. So if you could separate each into separate functions like an add function, a subtraction function, a transpose function, like that, if you separate it into different functions, from the main functions, the main function code will be less. The number of lines will be less. You simply have to you have to call that function, and the function executes and returns back. So that is the use of this function. So function, it is actually a self-contained block of program statements that perform a particular task. So if you want to perform a particular task like sorting, so sorting can be coded in a separate function. Okay. So it will be better if you have this kind of functions. So C itself is a combination of different functions. If you take scanf, printf, main, all these are functions in C. So we are simply calling scanf function. So actual operation or printf function we are simply calling. So the actual code lies, it is in the header file. So it will be executed somewhere. That code, the actual code is done separately. We are simply calling those functions and we will get the result after executing that function. So why do we need this function? The first thing we need is it is easier to understand and maintain. So if the program is divided into small chunks of program, then it will be easier to understand. So we can separate the whole program into small pieces of code. So it will be easier for the programmer to understand, and also it is easier to maintain. If you want to make any corrections, it will be easier to maintain that code also. Then secondly, lines of code will be reduced in the main program. So the main program will consist only of these function calls like printf, scanf, or we are just making those function calls. The actual program or the actual code is somewhere else. Okay, so we can reduce the number of codes in the main program, so it will be much more easier to understand. Another benefit is reusability. So the same function can be used in different lines of code. So printf, for example, printf function you are using in all the codes. The actual code is somewhere else. So reusability is there. You can reuse that code. So for example, if you are writing a code for sorting function, that sort can be called by different programs. Okay. So that is another use of this function, reusability. Then another benefit of this function is it protects data. It protects data means whatever variables you are using inside the functions will be visible only inside the function. So those variables will be protected. Nobody can access those variables from outside. So that is the advantage of using this function. Another thing is we can divide the workload. So if it is a huge software that is to be developed, we can make it into separate functions so that each function can be coded by separate different programmers, and then we can merge all these functions together into a large program. So we can divide the whole thing. So that is a use of this function. You will understand what is this function after this lecture. So using functions. So first thing you have to learn about function is how to declare or prototype declaration. So you have to declare these functions. Like you have declared variables like int A, int B, like that you have declared variables. Similarly, you have to declare the function prototype also. So for function prototype declaration is needed. So how to do this declaration? So before going into that, I will show one example of this function program. Then you will understand what is prototype and all. So this is a program to find the power. So if I want to find 2 raised to 5, so it is easy to compute that 2 raised to 5 using this program. So this is a function prototype. This line of code is a function prototype. So double, then this is a return type, then power, that is the name of that function, and within braces we are within brackets we are giving two variables. So double comma int, there are two variables, double comma int. So this is the prototype. So this is the prototype. This is similar to variable declaration. We are declaring that there is a function called power and its parameters. We will learn about parameters later. So its parameters are double and int. It has two parameters, double and int, and the return type is double. Okay. So that is a function prototype declaration. Then we have function definition. So function definition. So so this is the function definition. So this is the actual code of the program. So double power and we have some parameters. Then this is the actual code. This is the actual working of this code. So this constitutes the function definition. So declaration, then function definition, and then third thing is function calling. So we have to call those functions. So in the main program, we will simply call this function power of x comma n. We will be simply calling inside this function. So there are three things that you have to know. One is prototype declaration, then function definition, that is the actual code, and calling inside the main function. We will be calling those functions inside the main function. Okay. So if you see this printf, scanf, all these are all functions, but they are all inbuilt functions. And this is power is user built function. Okay, this is user defined function. So you'll see how to declare function. So function prototype declaration. So this is a syntax for function prototype declaration. There should be a return type, then a function name. We can give any function name. Then inside brackets data type, the type of data type of that variable. Then variable name you can give variable 1 comma data type variable 2, like that any number of variables can be given. This is an example, int max of int num1 comma int num2. And another way of prototype declaration is without giving this variable names also we can declare, like return type, then function name it is same, then data type list. We simply mention the data type list, like this we can mention int max int comma name comma int. So it means these two are integer type of variables. So we are not mentioning the names. So it is not necessary that you should name these functions, and it is not necessary that you should use the same names inside the definition also. We will see that later. So you can either declare like this without with mentioning the variable names, or without mentioning the variable names. We simply declare that type of variables that are inside the function, that are parameters. We can call this as parameters. Okay. So function name, we will see each one separately. What is this function name? What is this return type? And what is this data type variable one and all? So what is this function name? So function name, it is a name given to the function. So you can use any type of names. So same naming rules as variables. So whatever you have learned during variable naming, all those conventions will be followed in function name also. Then what is this return data type? It is a type of data given back to the calling construct. So return data type means it is a type of data given back to the calling construct. So that from the main function we'll be calling that function. So that function will be returning some value. So if it is returning a double kind of value, then that return data type should be double. If it is returning some integer type of element, then it should be int data type. Then the data type list should be mentioned. So data type of which of the variables to be transmitted by the calling construct to the function. So the variables, we will be transmitting some values to the function. When we call those functions, we'll be transmitting those values. So we can see this example, then you'll understand that. So here we are declaring this double. So it is double means this is a return data type. It means this function will be returning some double value. After computing whatever the code that is executing, it will be returning some double value. So if we see this inside this definition, we will learn about this definition later, don't worry. So inside this definition, we have a return thing, return result. So result is of double type. So we will be returning that result value. So it is of double type. So this is double. Then this is the name of the function that we are given. Then within inside this we have double comma int. So these are the types of variables. That is, we are passing two values x comma n. So x is of double type and n is of integer type. That is what is mentioned here. So in prototype declaration, we have to mention the variables we are passing. So we are passing x. It is of double type and n is of integer type. So that is what we are mentioning in the prototype. So it is a prototype of that function. So it shows that there is a function like this, and the name of that is this power. The return type is double, and we have two parameters that have to be passed. That is, one is double and the other variable to be passed is integer, and it should be passed in this order. Okay. Then these are some examples. Float, and this is the name of the function f2c, and float faren. So this means we are passing a variable faren which is float, and the return data type of this function is float value. Then double power double comma int. So we have already seen this. Then int is prime int, meaning we are giving, so we are when we call, we will be passing some integer value, and the return type of this function is prime function is integer. Then void print message void. So we have already seen this void. Again, void means there is nothing will be passed. So if you are not passing anything to the function, we are not passing any value to the function, then it is void. So it is not necessary that you should write void here. So then print message is the name of that function, and void is the return type. So this should be there, void print message. So void means it won't be returning any value. It won't be returning any value. So that is meant by void print message. Okay. So this function will be called from the main program, and inside the function something will be happening, and it won't be returning any value to the main function. Then this is another example. We will be passing an integer variable. This is the name of the function, and the return data type is void. That is, this function will not return any value to the main function. Then another example, float f2c float. This is the same thing. We are not mentioning any variable name here. We are not mentioning any variable name here. It is not necessary that you should mention the variable names inside this. Okay. So that is the function prototype declaration. So you have to declare whatever functions you are using, you have to declare it before calling that function. Before calling that function, that declaration should be there. Then second is function definition. So it is a collection of program statements that describe the particular task done by the program. So if you see this program, this is the function definition. So inside this function definition, the actual computation will be happening. So you will be calling this function to get the power of that values. If you give x raised to n, so you have to compute x raised to n inside this. So for that, the actual code will be written. So this is similar to writing the same code inside the main function. There is no difference inside the code. You can write any code inside. With these two braces, you will be writing the whole code. And there will be a return statement. As in the main program, we have a return statement. There will be a return statement. If we are returning some value, there will be a return value will be there. If you are giving, if the return type is void, if you are mentioning here void, then you have to mention simply return. So you have to simply mention return and semicolon. That's all. Okay. So it is a collection of program statements that describe the particular task done by the program. Then it consists of a function header and a function body. So if you see this program, this is a function header. It will consist of a function header. So I have given in comments, this is a function header, and this is the body of that program. This is the body. So this function body starts here, and all this function, all those computation will be happening here. Then there will be a return statement. Finally, there will be a return statement, and the function body will be closed with the closing brace. So we will see the syntax. So this is a syntax: return type, then function name, and within brackets you have to mention that data type variable 1 comma data type variable 2, etc. Everything should be mentioned, and inside braces you can write the body of the function. So this is the actual code of that function. So if we see this, you have to mention the variable names here. So this variable name should be there. Okay, this variable name should be mentioned inside the function definition. So here it is not necessary, or this is not mandatory, but when you write the definition, that variable name should be there. You can give any names for this variable. It is not necessary that you should use the same variable like x and n here. You can use any variable. If you want, you can use that y and m. You can use any variable name. Okay. So this is the general syntax. So list of variables, and in these list of variables are known as formal parameters, or simply we call it as parameters. Okay, these variables. So inside the function definition, these variable names are known as parameters, formal parameters. Okay, formal parameters. So variable names need not be the same in the prototype declaration and definition. So variable names need not be the same. That is, if you are mentioning here double y and int m, you can name it as double y and int m in prototype definition, prototype declaration, and inside the definition, it is not necessary that you should follow y is the same variable name. So here you have used y and m. Here you can use x and n. It is not necessary that you should have the same name. Then function calling. So how to call this function? So you have to call this function to execute that function. So you will be calling that function from the main function, or from some other function also you can call that. It is not necessary that you should call from the main function. Within a function you can call other functions also. Okay. So if you are defining your own function, inside that function you can call any other function, and inside that function you can call any other function. So function calling is done by using this syntax. There should be a function name, and you have to mention the variable 1, variable 2, etc. What all parameters that have to be passed. These variable, or you can simply call like this, or if there is a return data type, then you can use this way of calling. So function name, variable name, and equal to should be there. That is, whatever value that is returned by the function will be assigned to this variable name. So, or simply you can call like this. So if there are no parameters that are to be passed, there are no values that are to be passed, then you can simply call by this function name and within brackets like this. So, or you can call by like this. So you are not passing any value, but there is some return value from that function, and it will be stored in some variable. So these are the various ways to call this function. You can call like this: function name, variable list, then function name equal to, if there is some value that is to be returned, it will be like this. Or simply you can simply call this function without any return value, and also you are not passing. And this is another way. These are known as actual parameters, or we call it as arguments. So these are known as these variables. So inside the function call, these variable names are known as arguments or actual parameters. The other one is inside the function definition, it is formal parameters, and here it is known as actual parameters or arguments. So number of parameters in actual and formal lists must be consistent. So it should be consistent, meaning It should be consistent means, so if this is the example for function call, so this statement is the example for function call, so we are calling power x comma n, so it should be consistent with the function definition, meaning here if it is x, then x means x, that return, that type of that data is important, here it is double, so here also that variable should be double, and here it is n. N is of integer type. Then here also it should be integer type. The order should be like this. So if it is first one is double, second one is integer, first one should be double, and second should be integer. So number of parameters in actual and formal must be consistent. So parameter association is positional, meaning the first parameter will be corresponding to the first argument will be argument will be corresponding to the first parameter. Okay. Then actual and formal parameters must be compatible data types. The data types should be compatible. Then actual parameters may be variable, constant, or any expression matching the type of corresponding parameter, formal parameter. So it is not necessary that you should have variable names. Maybe you will be transferring some value also 5. Then you have to declare some variable int d, something like this. So if you are passing like this, so you are passing three variables. So first one is double, then second one is int, then you are passing a constant also 5. So that is actually an integer constant. So you have to mention int d. Okay. So we will see some examples. So this is the first example. So here I am using double power and double y comma int m is there, and this math.h is not necessary. I think I have simply included this. It is not necessary. So math.h is actually the mathematical functions are included in the math.h library, but I am not using any math.h functions. That power or square root, all these functions are there inside this math.h. So there's no need for this hash include math.h. The same thing. So this function prototype declaration, it should be somewhere above this function call. It should be somewhere above this function call. So it is not necessary that it should be outside the program. So you can include this program. If you want, you can include this program inside the main program also. So you can include like this also. It is not necessary that it should be outside, but it would be better if you declare it outside. It is not necessary, it is not mandatory that it should be outside, but the only thing is before calling this function, because when we call, if we are not using this thing, there will be some warning, and in some compilers it will be error. So if you are not using this declaration, what happens is when the main program, so execution starts from the main program. So when the main program starts executing, there is no need for this void and all. I simply include it. So when the execution starts from the main program, it will go execute line by line, and when it reaches here, there will be some error power because it is undefined. It is not defined anywhere in this program. So it should be, it is not declared anywhere, so it should be declared somewhere. So for that we are using this double power. So for that only we are using this this thing, that prototype declaration. Then in this main program, we have two variables, double variables, x and result, and we have n and another integer. Then you are asked to enter values of x and n. So this program computes x raised to n. So you will be printing x and the question mark. You will be scanning the value of x, and it is stored in double value. Then n value it will be asked. You will be scanning that n value. Then what happens is this x and n will be replaced by those values. So if you are entering 2 and 5, x will be 2 and n will be 5. So when this call happens, this control will go to this function. Okay. So this control will go to this function. Now x, here this x value will be replaced by the corresponding x value. So if you are given 2, it will be 2, and if it is n is given as 5, it will be 5. Now x is 2 and n is 5. Now result, we have initialized another variable here, double result. 1.0. So we have to declare separately. It is not necessary that you should use the same variable like this result. You can use any variable inside. So result equal to 1, then another integer I is declared. Now inside the loop we are computing this. So it will be repeated doing this, and you will be getting, so it will be multiplying 2 into 5 times. So 5 times this loop will be repeated, 2 into 2 into 2 into 2, that 5 times you will be getting, and it will be stored in the result, and outside the for loop you are returning this result. So when this return result happens, this value will be transferred here and that will be stored in this result. Okay, then you are printing this value. So I'll run this program. If you run this program, you will be asked this x value. So you can enter any floating value. So I am entering 2.4 and n value I am entering as 5. Then the result of x raised to n is 79.7262 is got. Now we will replace this. Now we have written x and n, and you have made it x and n here also, but it is not necessary that you should use x and n. I am replacing it other values. Okay. So I'll be using x double here. I am changing it to y and m. I'll change that value. Okay. Now I will change this value also. I'll use re, and I'll replace this with m, and I will use with x. Sorry, y, and return should be re, and here also it should be re. Okay. Now this program will also work. So there is no problem. 2.4 and 5. So the result is 79.62262. So it is not necessary that these names should be same. Only thing is this corresponding data type should be same. That is, x is of double type, then here also it should be double. And if it is integer, this should be also integer. Okay. Then this result, we are returning this result value only. That value will be stored in this result. Okay, so when we call this function, the execution will pass to this here. Then these lines of code will be executed. When this return statement is there, it will return back to the main program and the result will be stored. And we are printing this printf percentage. You can use percentage lf itself. I have used, okay, you can use lf itself. Okay, there is no difference. Okay, this way the execution happens. Now, so we have mentioned that prototype declaration should be there. It is not mandatory that prototype declaration should be there. The only thing is, if you are avoiding that prototype declaration, then this definition, so this definition, function definition, if it is placed above this main function, so I am just commenting this line. Okay, I have commented this line. So this line, this prototype declaration is not there, or else I will delete this line. So I will delete that line. Okay. So I have deleted that declaration. So prototype declaration is not there. But what I have done is I have placed that function called function definition above the main function. Now also there won't be any error in this program because I have placed it above the main function. Now there won't be any problem because the only thing is the function execution does not start from here. It will check for the main function. It will start from this main function. But during this compilation, automatically it knows that when this call happens, it automatically knows that this function is there. This power is already there. So if you are placing this function above this main code, then there is no need for this function prototype declaration. That prototype declaration is not needed. But it is not. It is better that you follow the convenient way to do this. Okay. So it is better you follow the convenient way itself. Okay. So you should include this prototype declaration, then function definition after all the functions. Okay. Similarly, you can include any number of functions. This is various function. If you want another function, you can write it down below like that. You can write any number of functions. And the main program, you can simply call these functions. Okay. And I will show another example. This is another example. You have already done this for to check whether a year is leap year or not. Okay. So I have a prototype declaration here. This is leap year. This means you are passing an integer value and the return value is of integer type. Now inside the main function, you have year and s as another integer variable. Then you are asked to enter an year and it will be stored in year. Then what you are doing is you are calling this leap year function and that year will be passed. So what happens is the control will be transferred to this function. So this is the function, and in this you are simply checking whether it is leap year or not. This is a condition. You have already done this program. This is a condition to check whether it is leap year or not. If it is true, then it will return 1. If it is false, it will return 0. So there are two return statements. So since it is if statement, it will execute either this one or else part. So if it is leap year, then it will return 1. If it is not leap year, it will return 0. So that 1 or 0 will be caught here. Then when if it is 1, if no, any non-zero value will be considered as true. So if it is 1, it means it is a leap year. Else it is not a leap year will be printed. So if you run this program, so you'll be asked to enter a year. So 2000, if you enter 2000, it is not a leap year. It is a leap year. And if you enter any other value, maybe 2001, it is not a leap year, will be printed. So this is the only thing. So here we have this prototype declaration, and inside that you are calling this function, and this execution will be transferred to this program, and you are simply checking whether it is leap year or not. You can returning 1 or 0. If it is leap year, you will be returning 1. If it is not leap year, you will be returning 0. So if it is leap year, it becomes if true. 1 means it is true. 0 means it is false. So if it is true means leap year will be printed. It is not if it is 0, else it is not leap year will be printed. I have one more example. This is another example. It is to convert temperature from Fahrenheit to Celsius. So this is a function, Fahrenheit to Celsius. So this is a prototype declaration. This is a function name f2c, and we are passing some float value and the return type is float. Okay, and we have the function definition here. So this is the formula for that. Float factor equal to like this, freezing, you know the formula for that. That is 5 by 9 into Fahrenheit minus 32. The temperature that is given Fahrenheit is minus 32. So that is the formula here. So we are using float factor, some value, then float freezing 32, then float Celsius. So Celsius equal to factor means 5 by 9 into Fahrenheit value. Whatever the temperature we got from Fahrenheit minus that 32. So that Celsius will be returned to the main program. So in the main program, float in temperature, we are using one variable temperature in Fahrenheit and temperature in Celsius. And you are asked to enter the temperature in Fahrenheit scale, and it will be stored in temperature ampersand, this temperature in Fahrenheit. Then you are calling this function. This is a function called f2c, and you are passing this temperature in Fahrenheit value. So the control will be transferred here, and now it will be stored. That whatever value that is there, it will be stored in Fahrenheit value. So if you are entering 225, then it will be stored in Fahrenheit value. Then that will be used here. That this Fahrenheit will be replaced by that 225. That value will be replaced. So you can run this program. So if you run this program, you will be asked to enter value for this. So I am entering 234. Then 234 Fahrenheit equals. So after calling this Celsius will be returned here. It will be stored in temp in C. Now you are printing that value, percentage F Fahrenheit Celsius. This percentage F will be replaced by Fahrenheit value equals this percentage F will be replaced by the whatever value we obtained, it will be replaced. So that is what we get as output. Okay. So these are the three programs. So hope you have understood this. So this is actually prototype. You have to remember three things. One is prototype declaration. Second is function definition should be there. And inside this program, there should be call of this program. Okay. So that's all. Thank you.